All right, let's do lesson 12.3 in your algebra book, page 655, multiplying rational expressions. Remember that a rational expression is just a polynomial in fraction form over another polynomial. All right, so here's an example of one. 5ab cubed over 8c squared times 16c cubed over 15a squared b. These happen to be polynomials that are all monomials, but it's still a rational expression. Now, remember how to multiply fractions. If you remember when you were a kid, let's say we have 3 over 7 times 7 over 8. We can multiply straight across and we can get 21 over 56. And if you wanted to simplify that, you end up with 3 over 8. Okay? That's a simple way of doing it. You could also learn 3 over 7 times 7 over 8. You could learn to cross cancel. That becomes a 1 because you can divide both by 7, 1, and you're left with 3 times 1, or 3, excuse me, over 8. And so, basically, you can cross cancel and then multiply, or you can multiply and then simplify. And that's the same thing you can do when you have a rational expression. You can either multiply straight across and then simplify, which is the example here, or you could cross cancel and then multiply, which is the example here. So let's look at, I'll call this method A, the straight across multiplication. So we rewrite our problem here. And we're going to multiply straight across. Five times 16 is 80. And we get an A and B squared, B cubed and a C cubed. A, B cubed, C. Okay. Then multiplying the bottom straight across, 8 times 15 is 120. And we get A squared B C squared. Now we can do factoring out. If we factor out of this, what we end up with is a number times a number on the top and the bottom. And what would we end up with?
Pizza!
What's up? What'd I get?
Did it get on there?
Oh yeah, it's on there. This is all on. What do we got?
That? I don't know.
Oh, cables for the elementary. They'll love it.
That's good.
Thank you. All right, let's continue on. When I multiply these two numbers together, that times that, what can I pull out of these two numbers that's common? I can see that a 40 goes into both of those, so I'm going to pull a 40 out of both of those. And what's left of the number? Well, a 2 is left over here, and 40 into 120 leaves me with 3. Now, I look at my A's. I can pull an A out of here and an A out of here. That one will be gone. So there's no A left in the second number over here, but there'll be an A in the second number down here. A times A is A squared. Same thing with B, except now I'm going to pull a B out of both, but it's going to go away in the bottom and still have a B squared on the top. So I'm going to get a B out of both, and I'm going to have a B squared on the top, and nothing down here because there's only one B in this side. And with the C squared, I'm going to pull C squared out of both. C squared, and that leaves me with just a C on the top. And then if I multiply that out, my final answer, well, these two cancel each other out, and my final answer is 2B squared C. So there is multiply first, then simplify. And I use the greatest common factor to simplify. Okay? And that's what we did here. We divided by 7 and by 7. Here we divided by 40 ABC squared. And what's left of that. Now let's do the same problem and we'll call it method B. And if you remember, method B here is cross-canceling. So let's write it out, our problem again. There's our problem again. Now we're going to cross-cancel. First thing I notice is 5 goes into 15 3 times, left with a 1. I can cross-cancel this A, left with a 1, and this A squared becomes A, the first. I don't normally write the first, but I did there for you. And then this B cubed cancels that B out, so there's nothing left here. There's a B squared left on the top. Now I cross cancel this way. I can divide the numbers by 8. Divide this number by 8, I get 1. This one I get 2. I can cancel out a C squared down there, left with a 1, and left with C up here. Now I multiply straight across. 1 times 1 times B squared times C gives me B squared 2. So there's 2 there. 2B squared C. And across the bottom, I get 1 times 1 times 3 times A, or 3A. And if you look at that answer, 2B squared C over 3A, we have the same answer. So both methods work. A lot of people prefer the cross-canceling method. All right, let's take a look at the next example. In the next example, I have x minus 5 all over x. So I don't have a polynomial anymore, I have a binomial. And I'm multiplying it times the monomial, x squared, over a trinomial, x squared 2x minus 15. I'm going to use method B, and I'm going to use that from all the time now, the cross-canceling method. So the first thing I notice is I can cross-cancel one of the x's out of here. I'm left with a 1. And this turns into just x. And then I look at this and I say, well, there's nothing to cross-cancel there. But because these are polynomials, I have to treat them as wholes, so I can't just pull an x out or a 5 and the 15 don't match. I have to match this whole number and deal with it as a unit. And this whole number is a unit. So when I have that, I look at a binomial and a quadratic equation, x squared x and a number, and I say to myself, well, let's try to factor the quadratic equation. So what two numbers, when multiplied together, give me negative 15, and added together give me negative 2? Well, I see that 5 times 3 has a 2 difference between the two numbers, and I want it to be a negative 2, so if I say negative 5 and positive 3, negative 5 times positive 3 gives me negative 15, negative 5 plus 3 gives me negative 2. So this number factors out to this x minus 5 times x plus 3. Now I have the unit, x minus 5 and x minus 5 in both places. They cross-cancel both to 1. And now I can multiply straight across. 1 times x is x. And 1 times x plus 3 gives me x plus 3. And that is my final answer, to simplify that term. Now let's look at example 3. Actually, it's example 2b. In example 2b, we have a squared plus 7a plus 10 all over a plus 1 times 3a plus 3 times a plus 2. So once again, I have polynomials, and remember, once I have a polynomial, I really have to put parentheses around each of these, and I need to treat them as whole units or factor them. So the first thing I see is I can factor this first term. I'm going to rewrite it. A and A. And what two numbers multiplied together give me 10, and added together give me 7. That's 5 and 2. A plus 1 stays on the bottom. And on top of this second number, I'm going to look, I can see that I can pull a 3 out. Both terms. So I'm going to say 3 times A plus 1. And then the bottom stays the same, A plus 2. Now I look to cross cancel, and I have an A plus 2, and an A plus 2, which cross cancels. And I have an A plus 1, and an A plus 1, which cross cancel. And so I'm left with A plus 5 times 3 all over 1, which gives me 3A plus 15. Just multiply it now. And there's my final answer. 3A plus 15. All right, now let's look at example 3. In example 3, we're given the fact that a guy in the Olympics ran 100 meters in 9.87 seconds. And they're asking us how many kilometers per hour did he run. And this is called a dimensional analysis problem, where you have to get the units of measure correctly aligned in order to get the right answer. Well, we know two things. We know 100 meters was run in 9.87 seconds. We want to convert seconds to hours, right? So we say for every minute, for every 1 minute, there are 60 seconds. And then we say for every 1 hour, there are 60 minutes. And then we say, notice we're timing these times each other. We've got seconds converted to minutes, converted to hours. But we've got meters, and we're trying to get kilometers. So we have to convert meters to kilometers. And there's 1,000 meters in a single kilometer. Notice that each one of these are conversions. This is seconds. Seconds over minutes is how many seconds in a minute, how many minutes in an hour, how many meters in a kilometer. And whether you put them on the top or the bottom is based on your trying to cancel them out. I knew that I had to put seconds on the top because I had seconds on the bottom here, because seconds cancel out. I then knew I had to put minutes on the bottom, or minutes on the top here because I had minutes on the bottom and they haven't canceled out. Now they canceled out. I knew that I needed hours because that's my final answer. I need hours, kilometers per hour. So I've got to have an hours on the bottom. So I'm going to leave that alone. It doesn't cancel. Notice there's no hours on the top. And then I need to get rid of meters and turn that into kilometers. And I did that by putting meters on the bottom because there's a meters on the top. They cancel. And if you'll notice, what's left is kilometers over hours, or kilometers per hour. So now all I do is do the multiplication. I've got 100 times 60 times 60 on the top, and on the bottom we've got 9.87 times 1 times 1 times 1,000. And if you did that on a calculator, I'll bring my calculator right over here and we'll just do it and see what the answer is. You get 100 times 60 times 60 equals that divided by 9.87 divided by 1,000. And we get 36.47 miles per hour, kilometers per hour. 36.47 kph. And that's approximately because I rounded. And there we've solved that problem. And that's called a dimensional analysis because you're figuring out how to cancel the units of measure and end up with what you're being asked. I asked for kilometers per hour, I ended with kilometers per hour, kilometers over hours. Everything else, unit of measure, canceled out. That's how you know you did all the calculations right, if all your units of measures cancel out correctly, and you're left with what you're looking for. All right, example 4. In example 4, Hold on here a second. And example 4, I lost my page in my book. There is no example. Oh, well, that is the end of that lesson. All right.